This is Farmer Lee. He works under the scorching sun every single day. However, this relentless exposure to intense heat really took a toll on Farmer Lee's health until one day, Farmer Lee could no longer withstand the heat and finally collapsed due to exhaustion. Farmer Lee dreamed of a fully automated farming system that is capable of solving all of his problems and make his job easier.
Introducing the solar-powered rotary farming system. It tackles 4 of the 17 Sustainable Development Goals. One of them is the affordable and clean energy, as the system utilizes solar panel to harness energy from natural sunlight. Next is the industry, innovation and infrastructure by introducing a unique and innovative rotary mechanism into the design. Other than that, implementing solar power system reduces greenhouse gas emissions and ultimately combat climate changes. With this, it will no doubt saving and protecting the life on land in the long run. There are several problem statements that needs to be tackled in this project. Firstly, is the need of implementation of green technology solution in the farming system. Achieving this can lead to a sustainable development in agriculture settings. Secondly, this project requires integration of energy-efficient technologies such that minimizing the energy input but also maximizing agriculture activity at the same time. Thirdly, the farming system needs to have a renewable energy system such as the solar-powered system to harness any energy from natural resources. Integration of renewable energy system not only reduces dependency on non-renewable energy sources but also ensures a steady and sustainable energy supply. Fourthly, the overall design of the farming system needs to be automized to improve the efficiency and productivity of the system. By implementing automated systems, we can reduce labor costs, minimize human error, and ensure consistent, high-quality agricultural output. Last but not least, we have to design a farming system that is able to provide an ease of access to the crops for harvesting purposes. An accessible farming system not only enhances the convenience for farmers but also contributes to higher crop yields and better overall farm management. On the other hand, the objectives of this project is to implement a solar-powered system into our farming system to harness energy from natural sunlight. Next, we will be introducing a rotating mechanism into design system for ease of access to the crops but also simplifying the watering system. Lastly, by utilizing sensors technologies into the design system to automize but also maximizing efficiency of the farm with other features such as solar energy storage, watering system and growing light.
With this automated farming system, Farmer Lee enjoying his summer at the beach. Farmer Lee can now monitor the condition of his farm through his phone. How does Farmer Lee monitor through his phone?
The Node MCU V3 microcontroller handles data processing and connectivity, integrating into IoT networks via Wi-Fi, while the BLYNK app provides remote monitoring and control from any smart device. This will be the ventilation system of our design. Our ventilation system will use a 5V 2-channel relay to control the fan, which activates when humidity exceeds 82% or temperature rises above 32 degrees Celsius. This ensures optimal air circulation, preventing heat stress and humidity-related issues, and maintaining a healthier environment for the plants.
Farmer Lee been enjoying himself too much that he has lost track of time. Out of a sudden the night bestow upon the sky and darkness engulfs everything in its embrace. But Farmer Lee doesn't worry about it.
Even during night time, the lighting system will provide much-needed light to the plants with a light intensity sensor that triggers the LED lighting system when light intensity falls below a set threshold. This system ensures that ambient light levels are monitored continuously, allowing for automatic adjustments to maintain optimal illumination for plant growth. By doing so, the system guarantees that plants receive adequate illumination even during the night, enhancing photosynthesis and overall plant health. Additionally, the light intensity levels are displayed in the BLYNK app, providing real-time monitoring and control for users. This consistent lighting condition improves overall plant growth and maximizes agricultural productivity.
Farmer Lee was chilling at the beach, but something bad's happen and happen again. Suddenly a strong wind gust blew past and Farmer Lee got blown away. And this is where the rotary system idea came from.
In order to produce a smooth rotary motion, two bearings were chosen and welded with each on the other side of the body structure to reduce the friction and also lower the load to be handled by the servo motor. The shaft will be passing through the bore bearing, with one end connected to the servo motor. The servo motor will be held on place with a bracket. The wheel structure consists of 4 sets of PVC tray containing the plants with each tray located at an angle of 0, 90, 180, and 270 degrees.
Farmer Lee is having a great time playing volleyball without single care about his farm. Why?
There are 4 sets of soil moisture sensors with their related modules, each connecting to the Arduino Uno A0, A1, A2, and A3. The soil moisture sensor module is used due to its ease of adjustment on sensitivity as well as stabilizing the signal. Its purpose is to allow Arduino to read the level of the soil moisture. The pump on the other hand required a relay as a switch to activate or deactivate it while the relay connects to Arduino pin 8. The relay model used here is a 5V relay module. Since the water pump will be switched on when soil moisture sensor detects that the soil moisture falls below a certain level, so the relay is to be set as normally open. When one of the soil moisture sensors detects low moisture, relay will switch on the water pump, allowing watering system to activate and water the plants for 5 seconds. After that, the relay will switch off the water pump. When one of the soil moisture sensors detects low moisture, a signal will be emitting to the Arduino. Arduino will send the signal to the servo motor and rotate it to an angle of 0 and stop. When the watering process is completed and pump is switched off, servo motor will rotate it back to its initial position. The process will be repeated when one of the soil moisture levels is lower than the threshold value. The 270 servo motor is chosen because it can rotate to a specific angle and stop as it is perfect for our rotating mechanism and design. Our rotary farming system has 4 sets of plants to which each of them are located at an angle of 0, 90, 180, and 270. Hence, the positional 270 servo motor fulfills the requirements. There are 2 wires from the servo motor that will be connected to the power supply, whereas another one is connected to the Arduino pin 9.
But where this system power supply came from?
This whole rotary farming system will be powered by 2 solar panels, and these solar panel will be the one to power up the servo motor, lighting system and ventilation fan system.
After tired of playing, Farmer Lee sleep again. And he finally awake.
Hi Brownie, recently I'm interested about the farming system. And I see the advertisement that you post on the Facebook. Can you explain more about it?
Okay, so this is what we call the solar power rotary farming system. So for this system, we have a LED system and also the ventilation fan system. Both of these systems are controlled by this IoT system right here.
Oh, I'm interested about the lighting system. Can you explain about it, how it works and show me?
Okay, so basically this lighting system is controlled by this photoresistor sensor. So this photoresistor sensor will detect the light intensity around this farming system. So when the sensor detects a low intensity of the light, it will automatically switch on the LED system. So I can test it out and show it for you by turning off the light. So as you can see, from this IoT system, the light is open when the light intensity is low.
Oh, I see. Can you explain why the fan is open?
Okay, so for this fan, it is controlled by this DHT sensor. So the sensor will detect either when the humidity or temperature of the surrounding is high, it will automatically turn on the fan. So right now we're currently in the room temperature, so the humidity is always high, so the fan will naturally be open.
Oh.
So, and then for the next is the automatic watering system. So for this system, we have 4 trays with each soil moisture sensor inside it. Okay, so when the soil moisture sensor detects like low soil moisture, it will activate the servo motor and rotate the tray to this position right here. And then the pump will be activated to water the plant from up here. So right now I will show you like a demonstration of how it actually functions. Okay, so for the third tray, when I take off this soil moisture sensor, it will rotate to this position again and start watering the plant. Okay, and for the last tray, when I take off this soil moisture sensor, again, watering the plant. And it's back to its original position.
Oh, I see. So amazing automatic watering system. So how about your power supply system?
So for our power supply, we're using 2 solar panels to power up this the system, to power up this servo motor, ventilation fan system, and also the LED system.
Oh,
So that's the power there.
oh, so interesting. So think about it. I think I'm interested to trust your automatic farming system. Can I purchase this?
Of course, anytime.
Yeah.
Alright.
Alright. Thank you.